Hello, today we are going to be working on L'Hopital's rule. L'Hopital's rule is used in finding limits of functions. So kind of interesting, we start the year doing limits and we'll end the year doing limits. All right, so quick review from the beginning of the year in finding limits. The first thing that we always did was just a plain old sub in whatever number we were interested in. If it worked, great. If it didn't, then we had some other tricks that we had to do. One of the things that we tried to do was some algebraic manipulation. By this I mean we could factor, we could rationalize a numerator or denominator, so we could do some of those things, and then we would sub in. If it worked, great. If it didn't, then we had to go on and try something else. One of the other things that we did was a sign analysis. This was generally used when we ended up with some non-zero constant over 0. And this is when we kind of did those one-sided limits. Where your answer went to positive or negative infinity, and you were trying to figure out the sign of this fraction, that original equation. We also had some memorized trig limits. These were all pretty much for as x approaching a particular number. If x approaches infinity, then we compared the degree of the numerator versus the degree of the denominator. And finally, if none of this worked, or in addition to these things, or in place of any of these things, we could take a look at a graph and think about what the y values were doing as the x values approached a particular number, or as x approaches infinity. Now, we did run into trouble way up here at step 1 when we showed 0 over 0. That's when we had to go on and try those other steps, steps 2 through 5. This result, 0 over 0, is called an indeterminate form. For example, when we had this indeterminate form, something like this, the limit as x approaches 6 of x squared minus 36 all over x minus 6, when you plugged in the 6, we get 0 over 0. 6 squared, 36 minus 36 over 6 minus 6, or 0 over 0. So then we had to try some of our other steps. And on this one, we would see to factor that numerator into x plus 6 times x minus 6 over the x minus 6. And then those x minus 6's would divide out, and we would be left with the limit as x approaches 6 of just x plus 6, which then we can substitute in, and we will get 12. L'Hopital's rule allows us to evaluate these limits, or evaluate limits that lead to an indeterminate form, by a different, maybe simpler method. His rule says, suppose that f of a equals g of a equals 0, and that f and g are differentiable on an open interval containing a, and that g prime of x is not equal to 0, oh my goodness, in the interval when x is not equal to a, then, all right, here it is. This says that the limit as x approaches a of f of x divided by g of x is exactly the same thing as the limit as x approaches a of f prime of x divided by g prime of x. So what this thing is saying is that when you substitute in this a, so you would do this by substituting the a into the function, that would give you f of a, which is 0, and down here substituting an a in, that would be g of a, which is also 0. So when you substitute in the a, we get 0 over 0, and we're stuck. Well, L'Hopital discovered that finding this limit is exactly the same thing as doing the derivative of the numerator and the derivative of the denominator and then evaluating that as x approaches a. Now I want you to notice here that this is not quotient rule. It is purely the derivative of the numerator over the derivative of the denominator. So when we look at this previous example, instead of having to factor here, what we could have done is, we know when we plug in, we get 0 over 0. So L'Hopital's rule says that you can find the limit as x approaches 6. Just do the derivative of the numerator, so 2x, over the derivative of the denominator, which is 1. Oh, now just evaluate that, plug in the 6, and we get 12 right off the bat. No factoring. That's pretty cool. All right, please join me on page 2 for some more examples of L'Hopital's rule.